Hello everyone, welcome back. My name is Bindu Shrim. I am studying in Sri Venkateshwara College of Engineering, Bangalore. Today, in this video, we are going to discuss about the vector calculus. And the agenda is introduction of vector, discovery of vector, theorems of vector, beauty of vectors, and applications of the vector. Then the first introduction, exploring the world of vector calculus. We all know that vectors are used in the mathematics field. So, welcome to the world of advanced mathematics. In this professional guide, we dwell into the vector calculus, uncovering the power that lies within, explore the techniques and principles that enable professionals to navigate complex fields such as physics and engineering. Get ready to unravel the mysteries of this mathematical art and take your skills to new heights. Then, discovering the vector. Vector calculus is a fascinating branch of mathematics that deals with the vector fields, their algebraic operations, and their derivatives. Join me on this journey of exploration and discovery to know about the vectors calculus. Then, in these vectors, we are using the theorems. Then the theorems of vector calculus are Green's theorem, a beautiful theorem that connects line integral surround a closed curve integrals over the region enclosed by the curve. It has the application physics, engineering, and the mathematical modeling. Then the next theorem is Stokes' theorem, a powerful theorem that relates the curl of a vector field to a surface integral taken over any closed surface. It is used in many fields of science such as fluid mechanics, electromagnetism, and geophysics. Then the third is Gauss' theorem, a fundamental theorem that relates the divergence of a vector field to a volume integral over any closed surface. It has a wide-ranging application in several branches of physics and engineering such as electrostatic fluid dynamics and the cosmology. This is about the Gauss theorem. Then the next topic is the beauty of vector calculus. Then the first is visual mathematics vector calculus. It is a beautiful and powerful way of understanding the physical world around us, from the fluids and the fields to surfaces and the shapes. Then the wide applications. Vector calculus is used in many fields like physics, engineering, computer science, and video game design, making it our strike tool for creative problem solving. Challenging and fun. Vector calculus is challenging at times but also deeply satisfying and rewarding when you finally crack those tough problems or when you see your work come to life in applications like fluid dynamics, simulations, or 3D graphics rendering. Then the next, wrapping up, applications and challenges. In these vectors, we are having the application. In the first, open problem. Some of the outstanding and challenging problems in vector calculus research today and opportunities for further exploration and innovation. That is divided into two. The first is a real world application and the second is join the journey. Then the real world application, recap of some of the real world application of vector calculus we have seen from fluid dynamics and electromagnetism to video game programming and 3D graphics. And join the journey, encourage the audience to continue exploring vector calculus and providing links to resources and communications for learning and sharing. Then understanding the fundamental concept of vectors. This is also an application in which before we dive into the depths of vector calculus, it is crucial to have a clear understanding of the fundamental concept of vectors. Vectors are mathematical entities with magnitude and direction representing quantities such as displacement of force, We will explore vector addition, subtraction, scalar multiplication, and dot product, laying the groundwork for more advanced calculations in vector calculus. And the third application is applying vector operations for calculus. Now that we have a solid foundation in vector operations, we can apply these concepts to calculus. Vector calculus involves differentiating and integrating vector fields, calculating line integrals, surface integrals, and volume integrals. By mastering these techniques, you will be able to solve complex problems in physics, engineering, and other scientific fields with precision and efficiency. And the fourth application is techniques for finding derivatives and integrals of vector functions. To find derivatives and integrals of vector function, we can use various techniques. The chain rule allows us to differentiate a vector function component wise. Integration involves integrating each component separately and adding a constant of integration to each component. We can also apply the fundamental theorem of line integrals, Green theorems, and Stokes theorems to solve more complex vector calculus problems efficiently and accurately. Then the fifth application is solving problems involving the vector fields. When dealing with vector fields, we can use vector calculus techniques to solve problems efficiently. These include finding divergence and curl, evaluating line and surface integrals, and applying Gauss and Stokes theorems. By mastering these techniques, we can analyze and understand the behavior of vector fields in various applications such as fluid dynamics, electromagnetism, and more than that. The sixth application is advanced topics in vector calculus, divergence, curl, and line integrals. Building upon the foundational concept of vector calculus, we dive into advanced topics that further enhance our understanding of vector fields. We explore the mathematical operations of divergence and curl, which allow us to behavior of vector fields more precisely. Additionally, we dwell into the integrals, a powerful tool for analyzing the circulation and the work done by vector fields along the curves. Through these advanced techniques, we gain a professional approach to solving complex problems in various fields of science and engineering. And the seventh application is practical application of vector calculus in physics, engineering, and computer science. Vector calculus has numerous practical applications in various fields. In physics, it is used to describe the behavior of electromagnetic fields and fluid dynamics. Engineers utilize it for analyze forces and movements in structure and machines. In computer science, vector calculus is essential for computer graphics, image processing, and machine learning algorithms. Understanding these applications allows us to apply vector calculus effectively in real world and solve complex problems. And the eighth application is tips and strategies for mastering vector calculus. To master vector calculus, it is important to approach it professionally. Here are the 8 tips and strategies to help you success. The first step is start with a strong foundation in basic calculus, understanding the geometric interpretations of vector operations. Practice solving vector calculus problems symmetrically. Visualize vectors, fields, and curves to gain. Familiarize yourself with common theorems and techniques. Work through challenging problems and seek help when needed. Apply vector calculus to real world scenarios to solidify your understanding. Then the ninth application is resources and reference for further learning. To further your learning in vector calculus, there are various resources and reference available. Textbooks such as Vector Calculus by Gerald E. Marsad and Anthony provide comprehensive explanations and exercises. Online platforms like Academy and MIT OpenCourseWare offer free video lectures and practice problems. Additionally, joining study groups or seeking guidance from professors can greatly enhance your understanding and mastery of vector calculus. Then the 10th question and answer session. It is the last in the applications. Engaging with the professional community. During the question and answer session, you will have an opportunity to engage with the professional community and seek answers to any questions you may have about vector calculus. This is a valuable opportunity to clarify concept, gain insights in experienced precautionaries, and expand your understanding behind what textbooks and online resources can offer. Be prepared to actively participate and take advantages of this rich learning experience. Mastering the art of vector calculus, it is a professional approach. We should have to keep it in mind about this. It's a very important. And the applications of vector calculus in engineering. It is used in aerospace, electronics, material science and etc. Then the first, aerospace. Vector calculus is used in study fluid dynamics, aerodynamics and the mechanics and the spacecraft navigation. Application include the design of flight vehicles, control system and satellite orbits. In electronics, vector calculus is used in model electromagnetic fields, circuit components and antenna designs. Applications include the design of electronic system, wireless communication and power generation. Materials science. Vector calculus is used to analyze crystal structure, surface properties and material properties. Applications include the design of materials, micro device and chemical. Then the last but it is not the least, that is conclusion. Vector calculus provides a powerful framework for understanding the modeling many of the phenomena that we observation in the physical world. It has for recharging applications to science or reaching the applications to science, engineering, economics and social science, and it is a cornerstone of modern mathematics. Thank you. Thanks for watching the video.